Algebra II 10.4c, Equations of Hyperbolas, Center as Origin. We got 13 previous videos. If you haven't seen the last two, you might become confused, and you can click on this description and watch those. And there's all 13 videos from Chapter 10 in this description. We can find the vertices, the foci, and the asymptotes, and draw the graph of a hyperbola centered at the origin by using the standard form of the equation of a hyperbola centered at the origin. So, back in 10.4a, we had this theorem. I still have it up here. And the equation in standard form of a hyperbola centered at the origin, with the foci on the axis and c units from the origin, is the quotient of x squared and a squared minus the quotient of y squared and b squared equals 1. And that's for when the foci is on the x-axis. When the foci is on the y-axis, we swap that y squared and x squared. See how they changed places? And that's where c squared equals a squared plus b squared for either axis. Okay? So these are the equations we can use when the hyperbola is centered at the origin. Okay? So here's our equation. We've got 9x squared minus 16y squared equals 144. The very first thing we do is we multiply each of these terms by 1/144th to set the equation to equal 1 and find the standard form. So, we know we can write this over a 1, can't we? So if we multiply it by 1/144th, this is going to make this 144 over 144, so it's set to 1, okay? And we multiply the other terms by this 1/144th, and we're going to get 9/144ths x squared minus 16/144th y squared equals 1. This can be simplified to 1/16th. This can be simplified to 1/9. We don't have to write that 1 there. We could put the x squared up there and the y squared up there, can't we? So now we've got x squared over 16 minus y squared over 9 equals 1. And these have to be squared. See? So that means this is a 4 and that's a 3, isn't it? And the vertices are at 4 for x, 0 for y, and negative 4 for x and 0 for y. Since c squared equals this a squared plus b squared, we can remove that little to exponent and put the a squared plus b squared into the radical sign, can't we? If we substitute our values in, a is a 4, so we have 4 squared. B is a 3, we have 3 squared. That's a 16 plus a 9. That gives us a square root of 25, which is a 5. Now we know our foci are at 5 and 0 and negative 5 and 0. And the asymptotes are y equals 3/4 x, see, because of our a and b values, and y equals negative 3/4 x. Now, to graph the hyperbola, first graph the asymptotes. So, the easy way is to draw a rectangle formed by the lines y equals 3 and y equals negative 3, and x equals 4 and x equals negative 4. So we draw our rectangle. And remember, the asymptotes aren't part of the graph. They just help us figure out the shape and direction of the branches of the hyperbola, okay? So, by extending the diagonals, we have 1 coming here and 1 coming here. We have our asymptotes. And then we draw the branches of the hyperbola outward from the vertices towards the asymptotes. So take a real close look at this. Here we've got our negative 4, 0, and our 4, 0, and we've got an asymptote here and an asymptote here, and you can see here's their little equations, and we can just draw our hyperbola curving. That's the easiest way to do it, is by putting that rectangle in there first. Now remember, everything we're talking about is for it to be centered at the origin, okay? So this is going to be plus or minus b over a, all right? If you look at our little equations here, we've got the blue b over the red a, don't we? Okay? So now that's going to swap. Take a look at this. The foci of the hyperbola can be on the y-axis. And the slopes of the asymptotes are plus or minus a over b. See that? It got switched around. Now that the foci are on the y-axis, when they were on the x-axis, it was plus or minus b over a. Now it's a over b. So here's our equation. We've got 25y squared minus 16x squared equals 400. First thing we do is turn this into a 1. So we multiply each term by 1/400th to set the equation to equal 1 and find the standard form. So that would become a 400 over 400. Now we've got 25 over 400 because 1 times 25 is 25, isn't it? And we've got a 16 over 400. We can simplify this. 25 goes into 400 16 times, so we've got 1/16, and we got 1/25 because 16 goes into 400 25 times. It's kind of neat how the numbers swapped places, isn't it? So now here's our equation. We don't have to write this 1 up here. We can put the y squared and the x squared up here. And now, look, we've got our y squared first, and it's the y-axis that the foci are on. See that? And this is the equation of a hyperbola with the foci and vertices on the y-axis. So the vertices are 0 and 4 and 0 and -4. And because c equals this a plus b, we can put our 4 and 5 in here, can't we? We remove that little exponent and then put these in the radical sign. And then we get 16 plus 25. Well, that's going to be a 41. So we have the square root of 41. And because that's not a perfect square, we can say the foci are at 0 square root of 41 and 0 negative square root of 41. We can get our calculator to get an approximation of this, can't we? And the asymptotes are y equals 4/5 x and y equals negative 4/5 x. We draw our rectangle. We have our xy values here. And then we can just draw the branches of our hyperbola, can't we? We can just put them in there. See? Now, if you're really confused about these asymptotes, you needed to watch the previous video, 10.4b, okay? Our next video, we're going to talk about a hyperbola and graphing by completing the square. And this is where the center is going to be at an HK value, all right? I'm going to add this to the Algebra II playlist, and there's going to be links to those 13 previous videos for Chapter 10 in this description, and the last 2 were really important. So I hope this was helpful. I hope you're having a great day. Keep trying. I'm really proud of you. I always say that, don't I? I am proud of you for watching these videos instead of watching some silly animal video, okay? I'll see you next video. Bye.